Yes, indeed. We have one question for the presentation from the UK, and it is that there are mainly small houses tested. What happens if you encounter big non-insulated houses? Do you have enough electrical power to generate a big enough temperature gradient? And do you manage houses that would require more than 10 kilowatts?
Yeah, the problem that we've had on a couple of houses, either bigger houses or ones that are, well, very badly performing, is the electrical load. You are limited to what electrical load we can put in. The first test that we did on this 1930s semi-detached house, we, instead of heating it up to 25 as we normally would, we were only able to heat it up to about 22 degrees because we were limited to one 16 amp ring on the ground floor, one 16 amp ring on the first floor, and a cooker or kitchen appliance one which was 30 amps. So we'd only got 62 amps at 230 volts to play with. So well, we were just praying that it didn't get too cold, and fortunately for us it didn't, and we were able to complete the test without sort of like any major things. But yeah, power supply can be a problem, but if you've got an idea of how much you're going to use, we had an idea from this first house, we were able to adapt the amount of heat and energy that we were having to put in there. So lowering it, or lowering the internal temperature, the test was the answer that we came up with.
Thank you. I think this answers the question. The following question is, did you consider about kitchen internal heat gain?
Yeah, well, these houses were unoccupied when we actually tested them, and so we were measuring all the electricity that was going into those houses. As far as internal heat gains from, or gains from solar, and that's why we have the weather station there. We use a multiple regression to regress against solar and wind, and we'll take the raw data and then we'll add in the amount of solar that we've got from that to give us our predicted figure. The other adaptation that we do, which I think is particularly important on these, is air tightness and ventilation heat loss. Our predicted figure isn't the designed ventilation heat loss. We actually use the same measured air leakage figure to calculate the ventilation for both. So changes, this is actually changes in fabric conductance that we're seeing there. It's not a change in sort of like ventilation as well.
Okay, clear. We have no more questions at this point. Thank you.